Whoa! What?
Seconds on channel. Power clear.
Let's see. Yeah, so my camera hasn't been working really well. I don't know if it's the computer's issue or what, but anyway, in this live stream, I plan to continue working on Aurora's, or not Aurora, gosh, I got so many projects going on. LOC-IV, my high power rocket. I plan on working on that design and open rocket. I started that on a live stream recently, but as you can see, it's definitely not finished. So there's a lot of work that needs done with it. I had to take some more measurements that I did not have while I was on the previous thing, but basically I'm gonna work with this for 30 minutes while I'm waiting for some epoxy to cure on this rocket actually right now. Hopefully, fingers crossed, willing to God that this thing goes well. It's on schedule right now. If I can get one more thing done by the end of today, it should be ahead of schedule by 2 days, which should hopefully allot me enough time to do some simulating before I get this thing inspected and all that jazz. So what we're gonna do, first thing is we're gonna edit this nose cone. So one thing I learned is, yeah, the dimensions and whatever, but we don't know, A, the material exactly, and B, we don't know exactly how thick it is and how dense it is. So there should be a way to custom add a weight to this component or a mass, or edit this mass down here somehow. I'm not exactly sure how. I guess the, let's see, override mass. Okay, so yeah. So it's, okay, so this I can add the mass, or I can make the mass something different. So when I measured it on my scale, let's see what I got. Payload, next. So the nose cone was 245 grams. So that's actually way lighter than what I actually have in the simulation currently, by half about. Actually even more, quite a bit more. So it's really good that I did this, because did you just see how much my center of pressure or gravity or whatever just shifted, because the nose cone is a completely different density. And then what I can do here, this main airframe is about 184 grams, so we can override our mass. This actually isn't too far off, but it still isn't as accurate as it needs to be. So we will click 184 grams, okay. Again, you can see my center of gravity and center of pressure got changed. So yeah, this is really good that this got figured out, and then I asked this question. And then each fin, whenever I get these freeform fins actually shaped. So let's do that next. So we will shape these fins somehow. I don't know how I'll do the fin tab. I guess I'll just, let's see. Fin tab. How long was our fin tab? Let's try getting the fin tabs figured out first. So it was 116.8 millimeters. So that would be 11.68 centimeters long. And how tall was the tab? It was, come on. How tall is the tab? Don't tell me I didn't measure it. 12.8. I don't think I measured it. Well, a good thing I'm on this live stream right now, so I'm going to measure this really quick. I think it was like 1.25 inches, but I want to double check. So, let's measure here. It is an inch and a quarter, so 1.25, yep. Good thing I checked that before I epoxied my last fin permanently into the rocket. That would have been not a great experience. I mean, I'm sure I probably could find it online, but that'd be a hassle. So tab height, 1.25 inches. So now we can see, okay, and I can shift the position of the tab. Okay, so we've got our tabs, now we got to get our fins. And these tabs actually need to be moved, but I'll take care of that later. So now let's mess with our fin shape. So I'm going to start with the bottom here. So 12.8. Let's add this up real quick. So 12.8 plus 116.8 plus 43.5 is the total length of this fin on the side that touches the tube. There's a name for it, I can't remember it. 173.1 millimeters shape. 173.1 millimeters. Somehow I've got to shape it like that. I don't know. Honestly, I really don't know how to do this. 173.1 is what I said. So that would be 17.31 centimeters, about. So, yeah, we got a way to go here. 17.31. So about this long. Let's zoom out. Now we got to figure out some other things. So I always forget how I am supposed to add another. Okay, there we go. That's how you do it. So I just added another point, and this point is, oh gosh, let's see. This might be tricky, honestly. I don't know how exactly I would CAD or design this in here. But let's just make like a general shape-ish right now, I guess. And actually, this guy needs to be moved up. Oh, no, he doesn't. It's fine. It does protrude out. I'm wrong. So it's something like this. I don't know exactly. So this fin is going up in centimeters. So this would be 6.07 about. So this is a little bit further. Can I edit these directly? Oh my gosh, I'm so dumb, I swear. 16.07. What was that? Oh no, wait, is it 16 or 60? Yeah, 6.07. And then this was the other one. This was 3.1. Okay. Oh, so it doesn't change. All right. And then I don't know how I tell it like what the distance between this is exactly. But in terms of length, I know the length, but I don't know. I must have to measure it in a different manner. Okay. And this guy up here needs to be on this line. Okay, so this guy needs to be exactly 6. This guy is exactly 19. So we'll go back and make that 19. Just trying to get this somewhat as exact as I can. I don't really know exactly how it's supposed to be shaped though. Alright, and then this guy needs to be, what? So 6 tall. How long should this be? Oh, I'm wrong. Hold on. 78 point, so 7.89. This is 7.89. 7.89. This is 6. And this is 19. Oh, you're not letting me change you. Why aren't you letting me change you? That's weird. I'll move it up. Oh, that's not 19. What the heck? Why is that less than when it was down here? Oh, it's back. Oh. Well, in that case, it needs to be the same height. So the same height was 7.89 then. Okay, and then the length is from, I'd assume, this thing. Well, it's not letting me see it, so I don't know. Yeah, so from that part of the fin is what I need to calculate. So in that case, it's a different length. So what I can do is take the overall length, which was 173.1, and subtract whatever distance the length of this part is, so that I know this distance to type that in. So it'll be 173.1 minus 60.7, and then that's the length I need to set it to. So 173.1 minus 60.7 is 112.4. So that would be 11.24 centimeters, wrong tab, from the back of that. So 11.24, enter. So that looks pretty close. Let me get the exact kind of measurement of this little piece down here so I know how that's shaped better. So this is going more smoothly than I thought, actually. I didn't think that this would be like this. I thought custom fins were a little harder to design, but when you have the actual physical fin with you, it's a little bit better. So from here, this is about, not about, it needs to be exact. Uh, 1 7/8 of an inch that way. So 1 7. Actually, you know what? Screw it. I'm just gonna get my caliper out. tape measure. This needs to be accurate, not guessed. This is going 460 miles an hour, so it needs to be right. So 23.9-ish. Actually, no, that's 23.6. Okay, let me write this down real quick. 23.6. And then, like, how high this is up. Let's take that measurement. And that should be 25.3. Wow, actually, let me double check. Yeah, 25.3. All right, 25.3 millimeters. And then what I'll do is I'll override the mass of each fin to be what I weighed each fin to be. And that way, it'll help me help provide me the most accurate data that I can. Now, granted, it's not going to be super perfect because this isn't it's going to be somewhat off in person. But the more I try to simulate it, the perfect I try to simulate it, the better I'll be prepared and I'll be able to expect certain things to happen more easily. So this is 23.6. So that'd be 78.9 plus 23.6. 78.9 plus 23.6 is 102.5, which is 10.25 millimeters back. So, oh, that is wrong. What did I do? What in the world did I do? 7.89 plus 2.36. Something's off. That shouldn't look like that. Okay, how does this thing calculate? It goes from the back here, like all the others, right? Yeah. So this point, how could that be so far back? Oh wait, am I looking at wrong measurement? Hold on. Trying to find the point of this thing. Yep, I'm looking at the wrong measurement. So this is 12.8. Oh, that's the bottom one. What am I? Oh. Hold on, this might be a little trickier than I thought. I got too excited too soon. So 25.3. Wish I could like change the view to match my drawing and make things a little less painful to me. So this is the rocket like that, and I'm messing with the point up here. So I need to know the distance of that point from the tip of the fin. So I'm just going to measure, let's see, can I get away with that? I don't know. Hold on, sorry. What is this, man? 20. Say it's 18 centimeters. That's what it looks like in person. Must be more than that. Must be less than that. I guess that's right. All right, we'll do with 19. That's about what it looks like in person. Okay, and then how high up is this? So this goes with respect to 0. So that guy is what I need next. Whoa, what just happened? Oh, it's still at 19. It's just a okay. So the distance then between that guy and the thing is 25.3. Right from the ground. Yes. Okay. So this is 2.53 centimeters is what it should be. Okay, that looks correct. That looks exactly like my fin. All right. So now let's go to fin tabs. The fin tab needs to be 43.5 millimeters back. And actually, I shaved off a portion of it, so I need to calculate that as well. But let's put you, that's not the middle, what are you? 0. Okay, that's correct. And then I actually shaved off today a portion of the fin, so I'm gonna actually CAD, I keep calling it CAD, I mean technically it's, I need to get that in here as well. So each one is approximately how much? Ah! That's almost exact. Is that a, exactly that. All right, let's see. By about 8 millimeters. So I shaved each one down by about 8 millimeters. So I'm gonna write that down. So what does it set to right now? 11 and a half. So all right, shaved fin tabs down by 8 millimeters. And I did this to get my centering ring to fit. Well, actually, that's not true. So it does fit, but I was told that if I allot a little bit more space, I can actually upgrade it in the future, the better motor retention system. So I went with that recommendation, but unfortunately I had to modify it just a tiny bit to get this to work. Everything should still be fine, just for this thing to clear. So whatever I just said, this in millimeters, minus 8, so that would just be 108, right? Oh wait, what am I saying? No, 107. Can't do math right now. So let me go back. Let me see what it looks like with 115, where it shaves it. Oh, so it does both. So that's an issue. So let's leave it like this, and then we need to put this with respect to the front of the parent component. And then shave it off now so we can see exactly, I guess. And then we can put it not in the middle, that's the issue. Huh. what did that read? 2.9 down, I think. Let's see, top. .9. No, that was not right. What did that thing read? Just put it in the middle. And when I set this to the top, what does it read? 29 millimeters. Okay, so this needs to be 29 millimeters from that. So if I put U to the top of the parent component, change U to 107, and then move U down by 29 millimeters. That should put me exactly where it is on the real rocket. Okay. Okay. That's it. That's exactly how my fins are on the real rocket. There should be, let me see, should be 3 of them. Number fins 3, fin can't. Okay, and then we need to override each mass to be approximately what it is in real life. So let's see what a fin measures in person. Measured this yesterday, so let's see. A fin measures 31 grams. So again, another case of being a lot thinner in person, but actually this might need to be, let's see how, I did not measure the thickness of a fin, oh, not a fin, a fin, so let's check that out as well, since we have to adjust it. So fin is about 3 millimeters, so I believe that's correct, 0.3 centimeters, yeah. So thickness is correct on the sim, so now we need to adjust the mass, like I said. And double check, it measured at 31 grams per fin. So we'll override mass to be 31 grams. Boom. See how much my center of gravity just moved? So this rocket looks like it's got a stability cal of about 1.96. Let's move the inner tube. Oh gosh. How much up? 1/4 of an inch, I believe. Oh, wrong way. So that's where it's positioned, and then gonna have to reposition all my fins. No. I just don't remember the rings being like this. Centering ring 1. Oh, that's the wrong one. So let's go with 3 first. That should be top of the parent inches. 11.25. Oh, that's true. I don't think I ever changed the inner tube to be the correct length. Length, inches, 12. Yep, that's incorrect. So we gotta fix that too. Let's see, what did it measure in person? I wrote it somewhere. 39.1 inch in tube, 11.25 inches long. So that's a whole 3/4 of an inch right there. That's not good. 11.25. I believe I said. And I wish I measured the mass of that as well, because it seems like all of my masses are incorrect. Okay, so inner tube is good. Centering 3. Obviously, I can't spell. And then this guy needs to be 11 inches exactly. Huh, why are you being weird? That ain't right. What is the parent component? Huh, this is really weird. Is the length not correct on the tube? Should be fine. Length. This is 11.25. 11 is less than 11.25. Not sure why. Let's see where it thinks 0 is. Oh, that's an issue. So we'll do it from the bottom of the rocket. And since I moved it up 0.25, it has to be 11.25 up. So I guess it is still correct somehow. It was wrong before. But in the other direction, obviously, goodness. Or we can just say minus 11, fine. Okay. That's that ring. This ring needs to get moved back some amount, actually. So let's move the U inches. 0. Bottom of the component. And then we'll just keep moving it up until it's exactly flush with this. So that looks pretty good. I think 5.7 is good. So that's good. Now we got to move the other one to be flush with the tab. So 0. We'll just move U like this. 0.1. Alright, okay. That's where we're at right now. Fins are good. Coupler's good. Motor mount's good. What else needs to be added? This centering ring needs to be weighed before it's epoxied. And then let's see. Parachute. I don't have a parachute yet. I don't know the weight of the parachute. I think it has 6 shroud lines, yeah. Diameter needs to be a lot more than 12 inches, jeez. Alright. Okay. And we'll add a shock cord. I don't even know what material the shock cord is made out of. Shock cord. 40 centimeters length. I think it's a 12 feet, 12 foot shock cord. I don't know how long that is. Not elastic. Kevlar, no. Not Kevlar. Nylon flat webbing. Not half an inch. Actually, is it half an inch? It might be, actually. Yeah, it's half inch, I would probably say. I mean, it's not... You know, let me just measure it. Let me keep guessing and measure it. God. Please remember that this is like a big deal. Guessing isn't getting anywhere. Yep, it's a 3/8, not a half inch. So that would have also screwed up my simulation. So 3/8 of an inch. Nylon, pretty sure. Okay. So we've got parachute in there, shock cord in there. We don't have rail buttons though, so we'll add 2 of these. I don't know the exact model on this, so what I'll do is just select a random one and change it because I don't have them easily accessible right now. Should be able to just click that and change it. So we'll do that. I'm just going to position them where they're supposed to be. So let's see. So side view, back view. And then where is it? Okay, so that's correct. Now we can go back to side view. And then I think, oh, I always forget. I think there's some way to rotate it. I always forget though. Sustainer, zoom, that. Oh, this way. Okay, so there's one. I need a second one though. Ooh, yeah, I don't know exactly where's the center of gravity? Oh, that's pretty high up. Yep, probably not going to be able to put a rail button where the middle of my freaking coupler is. Not good. So let's see. We will separate these by a certain amount. Not exactly sure. You know what? Let's just do one. Put it at the bottom. I'll make a separate one. That'll be easier. Parent component. Give you 0. Put you up, obviously, like a centimeter or two. This would be stupid. I'd never put a rail button like that. Okay. Then I'll make another rail button. Edit. This guy. Edit. This guy will go up more. Most likely about here on the actual rocket-ish. Let's say 40, 45. Don't know how correct that is. Now we can edit the appearance. So let's change this to be the actual color. Is in person. Oh, and then I forgot I can do 3D appearance too. So edit. No, that looks terrible. It's not black, it is a silver color. Probably won't be able to simulate that extremely well. Alright. Edit. Appearance as well will be different color. We'll make this the blue color that it is in person, about that color. We'll do the same for this guy. Edit. Appearance. Same blue. Okay. Okay. Can I edit appearance for both of these? These are black rail buttons. And it did do it for both. Okay. So, rail buttons are black. That's that. We'll do centering ring 1 needs to be the same color on the outside. Blue. Okay, that's the same color. That works. That works. Fins. We'll do our fins. Fin tabs, appearance. We'll make these the same silver as this guy. Alright, so that should do that. Let's take a quick look at it in the 3D view. This is our unfinished assembly. So this is basically what the rockets looks like right now. It doesn't have fillets and whatnot. But this is what it looks like. 3D finished. That looks pretty cool. Don't mind if I do. Yeah, that looks pretty cool. Wow. It's not letting me rotate it. I'm going to rotate it in here now. And then I'm going to real quick run a sim on it. Flight simulation. New simulation. About from sea level. I believe it's about 900 feet. I need to fix that. I don't know the exact location. I don't know the exact rod length. I believe they're like 8-foot rods. I'm not really sure. Let's just make them shorter to simulate like worst case scenario. And then let's see. Angle, I don't know. Obviously, don't know the wind. Shouldn't have too much turbulence if God willing. Per hour. And then we'll set this to 8. Alright, so this is that. Oh, I forgot motors. Dang it, what am I thinking? And then edit the simulation. No, that's not it. How do I get the motor in here? Rocket design, inner tube. Motor. It might be under this. So, new configuration. And then I'm going to try this on a motor somebody recommended me to use. And it is an Aerotech 165, I believe. So we will somehow, how do you, common name, sort, where's the thing that like you can sort it by, you just click that, right? Okay, good. Oh wait, Aerotech 165, H165. If that's even a thing. Let me see what he told me more exactly. Let's see. There was a man who was helping me with this. If it weren't for him, I wouldn't be able to do this. Let's see what level. So, give me a second. It should be an Aerotech 165. I'm not exactly sure. Goodness, where's Messenger? Yes, an Aerotech H165 is what I was informed to attempt in my simulation. 165 reload. Oh, so that is a 29mm motor. Okay, so we'll click U. Okay, and now I can go to my flight simulation. I can delete that. Edit this one because it doesn't have the proper information yet. It's per hour. Should be, we'll say 8. The standard deviation of 1. Direction, don't know. Length, it needs to be longer than that. 4. I'll say this as a default. Simulate and plot. And then let me just, oh shoot, why are you having errors? Oh, so I can change, oh, there's no, goodness. Of course there's going to be a total impulse. How do I change? Oh, I'm so stupid sometimes. So let's say a 10 delay. Okay, we are in the green for our simulation with the 165. Okay, so we are looking at a 477 meter apogee. So what is that in feet? Feet. So about 1,600 feet. That's pretty high. Velocity off the rod, 19.6 meters per second to miles per hour. 44 miles per hour off the rod. Wrong tab there. A deployment at 17, that's a little fast. That probably is going to zipper. Okay, optimum delay at 8 seconds. That's what I need. So if I could custom simulate that, that would be ideal. Can I type that? Yes. Okay. So let's type this. Run the simulation again. Perfect. Okay, so right there, that's our sweet spot. You want your parachute to deploy when there isn't rapid acceleration or deceleration, because then your body tube won't zipper. So about 8 seconds of delay on this motor. So deployment speed is actually right around apogee. So what is that? 2.65 meters per second, 2 miles per hour. That's pretty slow. Yeah, that's pretty slow. Yeah. So 3.7, about 3.69 miles per hour is the speed at which my parachute would deploy. That is exactly what I want. So 140 meters per second, 40 meters per second, 2 miles per hour, 313. So max speed of 313 miles per hour on this motor. On an I motor, I believe it can hit about 460-ish. 9-second till peak height. A flight time of 96.7 seconds, and it hits the ground at 5.39 meters per second, which is also pretty slow. 100 meters per second squared to I don't know, G force. And this is, yes, 176. Okay. Convert. G force. Where's my number? You didn't even convert anything. Oh. No. No, I want meters per second squared. Okay, you know what? Screw this. This is not working. Close the tab. Meters per second squared to G force converter. 176. Wow. So this rocket on this motor will experience about 17.947 G's of force, max acceleration. That is quite a bit. So imagine about 18 times the force you're feeling right now pulling you down to this earth. So this is looking good. Simulations are verifying it. I'm going to save this. Okay, and then save again. And that's it, guys. Thank you very much. Simulations are looking really good. I've got to go back in here and kind of fine-tune and update some things to get it as more or as accurate as I possibly can. But thank the Lord, everything is looking to be as if though it should work out okay. So, and we're stable. All right, so thanks for watching, guys. I have a fillet that I need to put on, or not a fillet, the last fin I need to epoxy on, and then fillets to worry about tomorrow. But thank you for tuning in, and that's all for now, folks.